Hello, and welcome to Practical Experiences Outside the Classroom for Science, Technology, and Mathematics students. I'm Amanda Mills, Assistant Director of Admissions, one of your hosts today. Our guests today are from the College of Arts and Sciences. Once we get started, they'll introduce themselves and share information with you about learning opportunities outside the classroom here at Stony Brook. Following the presentations, we'll save time for questions, so please add any that you have to the Q&A. And while we do not have any kind of general admissions information for you this evening, there are opportunities to attend virtual sessions entirely on the application process. I will post a link for you in the chat in a few minutes. This session is being recorded and will be available to watch on the Stony Brook Admissions YouTube page. I'll also post that link so you can bookmark it for later. Now, please join me in welcoming our first speaker, Dr. Hannah Nekvasil, the Director of Undergraduate Studies in the Department of Geosciences.
Thank you very much, Amanda, and welcome everyone. We promise to try to make it as exciting as we can because we're going to be talking about something that is exciting. And that is, we're going to talk about the opportunities that exist outside of the classroom. We all, whatever college you go to, whether it be community college, a university, you're always going to learn in a classroom. We hope that you'll do that. But what a research university allows you to do is to do a lot more than that. And so we're going to talk a little bit about some of the experiences you can have. And practically more importantly is what you need to do to prepare for those experiences. So for example, how does one even get into a research program? I mean, you're not going to be an undergrad. You're not just an undergrad. You're going to be coming in as a very young undergrad. So you're going to see everybody knows a lot more than me. So who I brought today to help you in understanding how one goes through this is my student, Christine, who you can see here waving there. She's waving her hand. And Christine has been a student for how long, Christine? 3 years? You can unmute yourself. So,
yeah, I'm a junior.
So she's a junior, and this is her second year of research. And she is acting like a grad student. She's running a lot of experiments. She's starting to design experiments. And she was in my classes. So she's got a lot that she's going to tell you about how she got into it and how did she choose an advisor? How did she get the courage to figure out what the research? So we're going to talk a little bit about that. And then in addition, I'm in geosciences and Michael's going to introduce himself too, is in astronomy. So we're in a way, we're, talking about experiences that you can have in the joint combination of planetary science and astronomy. What does planetary science have to do with anything? Well, a lot of geology research is in planetary science. So if you're interested in Mars, if you're interested in the moon, if you're interested in Venus, Mercury, well, you would be surprised, but a lot of that research is being done in the Department of Geosciences. So, one of the things that I want to be able to explain to you is how it is that you can find out what people are doing, because if you're going to get involved in research, you need to know what professor to ask. You need to know what they're doing. So the first thing I'm going to suggest to you guys to remember is the university has a great website. And the website lists also all the departments. And this is a research university. So what does that mean? That means one of the tabs that you often find in departments is the research that's being done. And I really recommend, whether you be interested in physics, astronomy, planetary science, geology, chemistry, whatever it is, that you go and look and see what research is being done. Because to be having research as one of your sort of additional educational factors, it's a great thing, and Christina's going to talk a little bit more about it, but you need to get to know the professor, because in many departments, you can't just be a total stranger and go up to the professor and say, I'd like to do research with you. That doesn't work that well. I'm going to give an example in my field. So Christina is doing experiments at high pressures and temperatures. Everything that she does is inherently dangerous. I have to be sure that when I accept a student, they are extremely careful. They know where their body is. So for example, Christine knows she can't turn around suddenly and let her shoulder bump a thermocouple, because that could ruin somebody else's run and it could damage the equipment. So little things like that. So you really are better off if you, once you decide the kind of thing you want to do, is to see if you can find a way for the professor to get to know you. At a research university, the people who are teaching you after the freshman level are generally researchers. Some of the freshman classes in calculus and so forth, that may not be the case. But as you get to the higher level courses, let's say start in sophomore year, the people that are instructing you are going to be doing research themselves. So they're great people to talk to and look up on the web. What are these people doing? Now I know somebody, I have a name. So if you want to get one of these wonderful experiences, you don't want to sit in the back of the classroom with your head like this, barely paying attention. Because if some student like that came to me and said, oh, I would love to be in your lab, I wouldn't believe them. They don't even love being in my class. But if they're in the front of the classroom and they're asking lots of questions and they're looking animated and they're smiling, I tell you, that may seem biased, but there's a natural tendency of, boy, I would really like to give this student an extra bit of education. Let them know. So what do they mean by research? This is literally taking someone like you, someone who comes in with 1,000 other students, and you are getting a chance to have a one-on-one relationship with the professor, one-on-one relationship with graduate students. You've gone from a huge body to a much smaller body where you are getting to get known. So in addition to that, what fun are you having? You're having the social fun of getting to know grad students who are just a little bit older than you, undergrads who may be your same age, professors who definitely, are a lot more experienced, and they're getting to know you. And why is that important? Whatever you do, you will need letters of recommendation. There's nothing better as far as letters of recommendation as to get an experience that's other than just the classroom experience. So research is probably the best way to do that. And of course, you don't want to do in research something you don't enjoy. For example, if you are a geology major, you're going to be taking a whole bunch of different courses. Some of them you're going to love, and some of them you're going to hate. There's almost nobody that can go through any major and say, I loved everything. And if you are, that's great. But most people will find things that they don't like. Well, you don't want to try to do research in that. You want to try to do research in something that you like, which will excite you. So the professor will see that you're excited. The grad students are going to want to work with you. And it will be an incredible experience all around. And how simple is it? Well, Christine is a good example. Christine, can you tell us a little bit about yourself and how you were able to get into research?
Sure thing. Okay. Hi, everyone. I'm Christine. I'm a junior. I'm a geology major. I recently took up a creative writing minor as well, just to fill up my last year. So when I was in high school, I knew I wanted to do research, which is not common for everyone, definitely not universal. Like, not everybody knows what they want to do that early on. I just knew that I liked being in the lab. I liked doing hands-on things, getting to see like what was happening in front of my face and like understanding. So when I got to Stony Brook, it was the week before first day of classes. I did research on the professors and what papers they were working on. I looked at their publications. I looked on their faculty website, pretty much. I looked at their profile. I looked at all the different topics they research. I looked at what they teach to see if I even want to take a course taught by them. Yeah. And then after that, I went up to their doors, said hi to them, and asked if they have a moment to talk about their research. I didn't say off the bat, like, hey, I want to work with you. I went and asked them. I had prepared questions about their research. The first person who I ended up going to was Lars. He's my major advisor. So he was the one sending out emails. He was the one who I already knew his name. So I looked him up on the faculty website. I went to go talk to him, and he didn't have room for undergrads in his lab. That did not stop me, as annoying as I was. I went to a couple different people, and the first person I found was Professor Dan Davis. I helped him out with his experiments for like a month, and then he retired. So that kind of sucked. But that first like month of helping him out with these like big like physics equipments, it was really cool. I did not know what was going on, and I didn't enjoy the work that much. So it was useful for me to know that maybe I didn't want to be lugging around heavy machines all day. So I went my first semester doing that, like trying to get into contact with people, but some people responded, some didn't. Then the next year, when I just happened to have Hannah as my professor, it was the class that I was looking forward to the whole time. It was igneous petrology, so that's volcanoes, volcanic rocks. Me personally, I've been obsessed with volcanoes since I was 10. So that was the perfect class. I sat in the front row. I was so excited. It was one of the like motivators to get me to pursue geology. It was growing up, going out to the West Coast and seeing those volcanoes and being so happy. And so when I got to that class, I was front row, like just like Hannah said, front row, like very like wide-eyed, asking all these questions. And then like a couple weeks later, she had told the class, like, hey, I take volunteers to be my TA. And like, if you're ever thinking about doing research, if you're ever thinking about planetary science, let me know. So I promptly emailed her later that day and asked to be her TA and to work and to do research with her. And she said yes to both, which was crazy. Thanks, by the way. It was awesome. And then I started doing some paperwork. I got in touch with one of the grad students, Natalie, who's also in the lab. And then like after all the like safety paperwork and stuff was done, I get to start like actually doing hands-on stuff. So I think what I really want to convey is that you do not have to be me to do research. You do not have to go up to every single professor and like be like, hey, can I talk to you? I like after I had no success with that, I kind of like was getting discouraged. But then the next year, like the perfect opportunity had been like, I don't know, like the perfect thing had happened. And I had just absolutely taken advantage of that. And I reached out, made contact, and it was probably the best decision I've made in my college career. And I am loving what I do now. So yeah, that's how I got into that.
And so I just want to remind you guys that Christine started off, Christine is a commuter student. She has not lived in the dorms, and yet she has still had every opportunity to do research and has just been incredibly successful. Now, Christine may be like many of you, where she has to earn some money in the summer if she's going to pay her bills. So you could ask, well, what happens in the summer? Well, the university has many opportunities. So we have a actual research program for undergrads that really takes some of the weight and the burden off the faculty, but more importantly, they have money. And so Christine, for example, was able to receive a fellowship for her summer research, which allowed her to stay and do research in the lab. And then she gave a presentation just like she would at a conference. And what Christine learned during that summer, as well as what she had started to learn in the semester, was the whole idea that research is fluid. You start thinking you're going to do a project, and suddenly you come up with all these questions. And as she started maturing the research, she started realizing, hey, I can formulate these questions. I can formulate and design experiments to try to answer these questions. I can learn techniques like X-ray diffraction and start using them independently. I can start using a lathe and making precious metal capsules, little tiny platinum capsules, so forth. So, a lot of that discovery was what she learned about herself and her own capabilities. So it's really it's a journey of self-discovery to go beyond the classroom and start getting engaged in these other learning scenarios. So I think I better stop at this point. I will give you a summary slide towards the end and let Michael introduce himself and talk a little bit about whatever he would like to share with us tonight.
Great, thank you. I'm going to echo a lot of what Hannah said. My name is Mike Zingali. I'm a professor in physics and astronomy. So I don't know how to use a lathe or do any of that stuff that we were just told Christine is an expert about. So I would definitely knock over a thermocouple in Hannah's lab. I don't do experiment, and as you were told, you know, you need to find what your interest is, right? You may not love every class that you take. I do computational work, and I work with a number of undergraduates that that work on our research codes, and together we all try to blow up stars. Basically, that's what our research is. And you know, it's a very different style of work, and it's a lot of fun. And I'll tell you a little bit about how I'm going to echo a lot of points that Hannah said about how you might get involved in things. So just like you were told from Hannah that geosciences encompasses a lot, astronomy also encompasses quite a bit, right? We try to cover the whole universe and everything in it. There's people who work on the largest scales and try to understand the origin of the universe and how it evolved to the present day. And there's people who work on smaller scales, or small is still pretty big, and try to understand how stars form, or even how exoplanets form around other stars. And of course, there's a lot of parallels between exoplanets and the planets in our solar system. So there is a lot of commonality at that level between the geosciences and astronomy. And our group has people who do research across all of those ranges in astronomy. For our majors, typically what happens is when you come into Stony Brook, you're going to start out on a path that is not all that different than physics. You have to take, and probably not all that different than geosciences. You have to take the math and the physics to get started. You're going to take these introductory courses. One of the things you should, if you know you're going to be interested in research, one of the things that you should do, again, echoing what Hannah said, is try not to be anonymous, right? You don't have to sit in the front row. I mean, bravo, Christine. I never did that when I was a student. But here's a little secret. Go to office hours. Professors have office hours. We hold this time to help students answer questions. Get yourself known to the faculty who you're taking the classes with. As you were told, these are the people who will be writing you letters of recommendations for fellowships and for other opportunities all throughout your undergraduate career. So getting to know and standing out a bit from your peers is something that can start as simple as just going to office hours and getting to know each other. In astronomy, every year, typically at the end of the fall, we have what we call the town hall meeting, where all of the astronomy faculty get together. We invite all the majors and minors. We tell them about all the research that we're doing. Is a great opportunity to meet the faculty at that point. We also talk about all the major requirements. We talk about research opportunities both on campus. As Hannah mentioned, the school has a program called Eureka. I never remember what it stands for, undergraduate research, something. But it's a great program, and it can provide you with the funding to work over the summer. Most of us have research grants, and we pay undergraduates directly out of our research grants as well to work with us over the summer. But you can also learn about research opportunities that will take you off campus. And regardless of where you end up as a student, you know, I'm sure we'd love for all of you to come here, but everyone can take advantage of research programs that are offered on the national scale. All the different funding agencies, National Science Foundation, Department of Energy, those are the big ones that we get our funding from, have research opportunities for undergraduate students, and our students at Stony Brook do very well in getting these opportunities, and they go somewhere, all expenses paid, spend the summer doing research somewhere, and then they bring this knowledge back with them when they come back. We also have a seminar. It's a 1-credit seminar where basically you are the audience, and all the astronomy faculty, 1 per week, come and they give a talk, a presentation. This is what my research is. And again, it's a great way for you to get some exposure to what sort of research is done on campus. And finally, and I think this is true with Hannah, and I don't think you mentioned it, we have an astronomy club, and I think there's a geo club,
It's geology club.
made up of undergraduates. They're very active, very friendly. The astronomy club is apparently one of the bigger clubs on campus now, and they're a great font of knowledge for everything that goes on in our program. And they can also tell you about research opportunities, what works and what worked for them, and so forth. So if you're interested in the subject, find out about the club. And both of our majors have their own respective clubs, and be involved. The astronomy club, for instance, they use the telescope on the roof of our building. The weather's not very cooperative right now, but sometimes it is, and even in Long Island skies, you can see some neat things. I have a little list here. I'm sort of quickly looking over my list. I would say that usually the time to really start thinking about research would be in your 2nd year. And it sounds like Christine might have been the exception again. In astronomy, everything, even if you're doing observation, or if you're like me, you're doing computation, you need to get the computer skills under your belt. And all of our majors take an introduction to computing. You learn Unix, the Unix command line. You learn a programming language, and so forth. In astronomy, or in our group, we use C++ and Python a lot. But you're going to be doing some coding if you get into astronomy. All of the observational data that you work with, if you work with data from a telescope, is digital. And you build your scripts to read in that data, to do analysis on that data, and to come up with your final research products. For us, all of our simulation codes are, they're big codes. They're developed over decades with lots of people running, and you need to get some comfort in programming to start to make a difference. And you'll be trained in those skills. And so usually after your 2nd year, that's the ideal time to start getting involved in research. I think one of the strengths that our program, and I'm sure it's true of geosciences as well, offers to students compared to some other places, is that there are so many research opportunities. Our department's big. Physics and astronomy is like 75 faculty or something like that. Within astronomy, we're 12, and all of the faculty work with undergrads. Usually we'd work with like maybe 2 at a time. I think I have 3 right now, 3 undergrads that I'm working with. And so there's lots of opportunities, and you can work for credit that will count towards your major during the semester. You can work for pay over the summer, or maybe even during the semester. It all depends on how things work. There are opportunities as well for that. Eventually, you're going to decide what you want to do with your life. Maybe. I think I'm still deciding that. But if you decide that research really is your thing, and you really want to go on and have a career in the sciences, you're going to want to go to graduate school. And having the time where you have done some research as an undergraduate is going to be very important when it comes time to applying for graduate school. The application process for graduate school is sort of changing, and it's de-emphasizing things like standardized tests. And it's emphasizing more now the research experience that you may gain. And again, I think this is one of the strengths that we can offer for people. I can't even read my writing anymore. Let's see. Yeah, that's what I was going to say. There is, as Hannah said, there is a lot of funding opportunities on campus, so that you don't have to make a choice between having a job to support yourself and doing research. The campus has opportunities that can provide you with funding, and the researchers, us, we have money that we can pay students for to help contribute to our lab. A lot of the students who've worked with me have gone on to graduate school, have been part of papers, have led papers that have come out of our group. And it's the same with the students who've worked with my colleagues as well. I think we're right at the midpoint in the hour, and I think that's when we said we were going to switch to questions.
Yeah, I just want to just very quickly just summarize a couple things before we get to the question and answer. And what Michael said, you'll see the same thing echoed here, but sometimes it helps just to see it written down. So I'm going to just very quickly share screen and just go over some of these points that so I hope everybody can see my screen here. I'm going to hide floating meeting controls. And this doesn't really matter if it's Department of Geosciences or anything else. Basically, when we're focused here, we've focused a lot on research. And as you heard from Michael and from myself, that you can do research in-house or you could do it outside. If you do it in-house, there are ways that you can get funding. We have the Eureka program. There are a variety of scholarships that go along with that, like Christine got the Valet scholarship. There are faculty research grants. And the pros for working in-house is that you can work with a faculty member that you know. You can continue the research after the summer. For most students, they haven't finished the research project in the 6 to 8 weeks of a summer program. And you can continue it very likely afterwards. You can live at home and not pay for housing if you live nearby. But what are the negatives of doing in-house research experiences? Often you don't get housing paid for, which means that if you don't live nearby, it's a little harder to stretch those research dollars. You're often just 1 or 2 undergrads might be in a lab. You're not in a group of your peers, often if it's not a formal program, but rather just in a research lab. And of course, you're not getting any new exposure to schools. But there are many outside opportunities. There's something called research experience for undergrads. There are a lot of them in planetary science. NASA funds a lot of them. NSF funds a lot of them. There are many, many out there. You can literally Google them and find a lot of them. And what's great about them, it gives you new exposures, new experiences. Usually you come in with a group, so you have a whole peer group that you work with the summer and you feel you're getting that social life also. And these things generally pay for housing. But of course, there's some cons too. That research ends after a fixed number of weeks. You don't really know the faculty or grad students you're going to be working with a priori, so you may go there and find that you really don't care for that faculty member or the team. But both have pros and both have cons, and that adds to your education. And as Michael says, if you want to go into the sciences and continue after the undergraduate degree, and you go to a research university like Stony Brook, it is expected that you've been involved in research. So there are 2 different ways of doing that. So for getting something in-house, we talked about standing out in class, doing your homework, finding out what grad students are doing, what professors are doing, select a professor and ask. It's not going to fall into your lap. You need to be proactive. For the outside opportunities, you generally have to fill out a formal application and you need recommendation letters. So you need professors, sometimes 3 people who know you, and no, your high school teachers do not work on this. You really need professors from the university. And that's something you should be thinking about from day one. And that getting to your professors to know you. What we didn't touch upon were 2 other things I think I want you to remember also exist. There are internships, and some of them are paid. And this is particularly useful for those of you who would like to go into industry after you graduate. So for example, in my field, a number of the students decide they want to go into the environmental field. And so they contact environmental company And they asked them, do you have any internships? Are you taking on any students? And so the student ranges with that company to work for them, sometimes in the summer, sometimes during the academic year, that they would be in school part-time and they'd be working. And what's great about that is that often those transition into jobs after they graduate. So that's another very valuable thing. And it's particularly good if you know you're not going to want to go to grad school, or you'd like to sort of play the field, you're not really sure. And the last one, before we start taking your questions, is to remember that not every one of you is planning to go into research. There are other ways that you get experiences outside of the classroom. And I think one of the most valuable ones is teaching. So you heard Christine say that I accepted her as a TA. A TA means teaching assistant. And a teaching assistant, when you're an undergraduate teaching assistant, you can take it for a course. You actually get credit for that course. And what it means is that now suddenly other students are going to call upon you for questions, because you as an undergrad are a lot less intimidating than the professor. So they would rather ask you what they think is a dumb question than the professor, which is great because that makes you have to explain. And the minute you have to verbalize something, it helps your brain figure out things. So Christine, by TAing for my upper level, my 400 level course, she learned so much more than just when she had gotten her A in the class. So my point being is that experience keeps going when you're a teaching assistant. And if you decide that you want to go, we have some outstanding teaching programs. There are, in physics, for example, you can go for a combined bachelor's degree and then a master's of teaching. In chemistry, in geoscience, earth science, etc. What looks really great on your application is to have some teaching experience. So how do you get those? Same thing, you got to stand out. I guarantee you, if someone is sitting like this in the back of the class, I don't want them to represent, be someone that the students are going to for questions. I would rather take a student who doesn't know as much, but who is eager to try to help, because if they don't know something, they're going to do their homework and try to come back and help the students who have questions. So again, you want to stand out. And if you hear anyone say, I'm looking for a TA, be the first in line to get that position. And again, you can always ask around, does anyone need a TA? And chances are, if you know the professor, they're going to be much more willing to accept you than if you don't know the professor. So because it's a matter of, I am trusting my TA to be able to answer questions, to develop review sessions, to be helping me with grading, taking on a position of responsibility. It's a tremendous growth position. So I really recommend that you guys remember that there are multiple ways to get an education outside of the classroom. And that's a very important part of your life at a research university such as Stony Brook. And I think at this point, we will turn it over to our coordinators here who will help us with questions. I'm going to go ahead and escape here. I'm going to stop sharing. So we're back to where we started.
Thank you all so much. That was wonderful. We have very excited audience members with lots of questions. So
Excellent.
This definitely, sparked the interest of our guests. One of the questions that came in, I think they might have missed discussion of this earlier on, but was, can freshmen do research?
So I'm going to just quickly jump in for a moment. There are actually some programs on campus that really try to encourage students to do research in their freshman year. The WISE program, for example, on campus, it's Women in Science and Engineering. That program is geared towards getting women into research as quickly as possible. The problem is that in many cases, you don't know enough to really get as much benefit from a research experience at that level. And many faculty will feel you need to be in a more of an upper level class before you really are mature enough to be able to go away from the background and move into uncharted territory, which is what research is all about. Michael, do you want to add to that?
I think I would agree. I think, when people come to me and if they're freshmen and they say they want to do research, I would usually say, let's wait a year. I want you to have taken a few semesters of calculus, the intro of physics, and for the work I do, our introduction to computing, so that you already have some background in the type of computing that we do in Astro. Starting in your sophomore year, you still have plenty of time. I've worked with some students for 3 years, and it sounds like Hannah's doing the same right now. So that's plenty of time, and it's good to get a good start in your classwork, and you'll have time. You don't have to start right off in your first year.
There's no hurry, in other words.
Yeah, there's no hurry, and the transition into college can be a big transition, both academically and also in your own personal life. If you're living away from home now for the first time, take that first year and enjoy it and make the best of it and do well in your classes. There's plenty of time for the research.
Yes, great advice. All of our incoming students always want to rush, 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 and then they realize during freshman year, oh, I have to slow this down.
Yes.
The pace is too fast. Okay, so we'll try to get through these questions. They're coming in quick. This is a great question for Christine. Do students typically spend most of their free time doing research? I'm sure you do other things, right, Christine?
Yeah, I absolutely do other things. So the general thing that I've heard is like, for every 1 credit hour you take, it translates to 3 hours of homework, which is insane. That's for calc. You do with research, you could be a lot more flexible. It depends on your own schedule and your relationship with the advisor. It's really not rigid. You can have some flexibility, and I would say I do not spend my whole time doing research. In fact, I have a part-time job and I have a bunch of credits and I still have a social life. So it is not the only thing you'll be doing. If you decide to do research, you can still have a life outside of it.
And faculty recognize that. I just can't emphasize enough that an undergraduate student is not a graduate student. Graduate students, after a couple of years, that's all they do. They do not take courses. The undergrads, we recognize, are taking courses, and we don't want them to just grow in one direction. Joining clubs, having a social life, volunteering for things and causes, even running protests on campus. These are all really important parts of being an undergrad.
And we have a question. What is the Geo Club like?
Yeah, I know. I didn't want to interrupt you guys while you're saying it. There is no active geology club right now for the last year or something. Nobody has been
Dan
actively
retired.
running it, which
Dan
sucks.
retired.
Yeah. So there's been a little bit of discourse within some of my geology friends whether we want to start the club up again. We're trying. I don't know when that's going to happen, but we're really trying to get the geology club back together. But in the meantime, I'm actually on the executive board of the Nature and Recreation Society, which is a new club. We're going to organize hikes and camps. So very geology involved if any of y'all are interested.
Perfect. And I think this was also discussed, but for clarification, the question is there a grade point average requirement if I want to do research at Stony Brook?
Very good question. And I'm going to jump in again. Sorry, Michael, feel free to interrupt me at any point. There is a GPA, put it this way. Your GPA is for life. Your GPA is what gets you into grad school, what gets you into professional schools, what gets you scholarships, fellowships, etc. So no, a GPA, there's no cutoff, for example, in geosciences where someone can't do research because their GPA is too low. But we try to get our students to understand from day one that they must protect their GPA. And if they're struggling, they should not be spending time doing research. They need to be spending their time getting the help to get the better grades. Because if you have a low GPA and have done research, that's still not going to help you getting into grad school. It may be better than having a low GPA and no research. But really, we emphasize to the students that a GPA is an incredibly important thing. And so, Michael, why don't you may have a very different philosophy in astronomy, but that's something we do emphasize.
Yeah, I kind of would say the same. I always tell students when they're working with me, your classwork comes first,
Yep.
right? But also I've never asked an undergrad who works with me what their GPA is. So I typically don't care. So the classroom skills and research skills can sometimes, not
Be
always
orthogonal.
overlap. But I would emphasize that, the classwork has to come first. You need to be able to complete your degree. And if you're not doing well in your classes, you're going to have to retake classes, and that's not good. So your classwork has to come well, but there are research, I can't speak for every faculty member, but there are research opportunities for everyone, I would imagine.
Great. And another question, really more for Christine. How's university life at Stony Brook with all the classes and research and projects? I think they might be asking about balance. How do you do it all?
It's taken a while to perfect, for sure. It for my first semester, definitely a learning curve. I did not have much of a social life my first couple weeks into the semester, but that was mostly a me thing. What really helped me like really get into social life is once I start like my classes, once I know my schedule, like after the first couple weeks, I know where I'm gonna be at like all times of the day. So I know what clubs I can go to, like what events, if any. And I would say the university life, especially with like all like the whole like university wide events, like Earthstock is awesome. Like a whole like day where there's whole like environmental projects everywhere, and it's awesome. I would say that for me, university life, it's like every single day is different for me. Like I have different times and different days to do my homework, to go to class, to go to research. So I end up going to research like after I've planned out all my activities for like the day, because I can't even go to the next day yet. I have to like stay in one day. So taking it like an hour at a time is all you need. It's like if you know where you're going to be for the next hour, you're golden.
Excellent. And so Michael, you answered this. Does Stony Brook have any programs involving astrobiology, which is something I hadn't heard about, but you wrote, within astronomy, we don't have anyone working on astrobiology, but there are several faculty working on exoplanets. So hopefully the person who asked knows what that means. Thank you, Michael.
Can I follow up on that? May I follow up on that, Amanda? So a good example of astrobiology. So when we are looking on Mars, so for example, a number of our faculty are actually on some of the Mars missions. So they are deciding where the rovers go and get the data. And of course, NASA is funding our research on Mars to look for evidence of past life. And what we use the astrobiologists for is to give us an idea of what is the signature of past life. What should we be looking at? And so we have a major in our geosciences, Earth and Space Sciences major, where we have tailor-made a set of courses that would allow a student, for example, to take courses in chemistry through organic chemistry, to take biology courses and take courses in geology to prepare them to go to graduate school in astrobiology. And that is a unique major, and NASA is still funding astrobiology. There's an entire program for astrobiology. So it may not be in astronomy, it's more in geoscience, this astrobiology, because it's on the planetary exploration of the terrestrial inner planets that we are looking for currently for life. But the gassy planets, eventually we may be looking for that there also. So that is an important field. And I would like to just mention one more thing in that regard. We have, for example, my lab has recently just finished up a research project that involves the medical school. And what we're looking at is what NASA has asked. NASA has said, we're going to put in the Artemis missions, we're going to start bringing astronauts back to the moon. What are the hazards that these astronauts will face? And our group was charged was to determine the toxicity of the lunar dust, because the lunar dust turned out it entered even into the lunar modules. You can't get around it. It's very sticky stuff. It has very different properties than terrestrial dust. So we worked in the medical school for all the toxicity testing, how it damaged lung cells, etc. Excellent opportunity for research for undergrads who are interested in the combination of either astrobiology or medicine and geosciences. So again, these kind of interdisciplinary majors can be developed, and I do want to encourage the students who are interested in these kinds of unusual fields to please consider Stony Brook, because we are unique in that regard.
Nice. So we had a question about percentages overall. So obviously I won't put that on all of you. It's my recollection that 60% of undergraduate students have participated in at least one research program or project or some sort of research by the time they graduate. But there are other percentages that show that some do more than just one or are involved in other sorts of experiential education, kind of practical experience. And that would probably be closer to almost 100% because there are some requirements in the Stony Brook core curriculum. So if you're looking for exact percentages, I believe there's a research part of our website, and you can always email enroll@stonybrook.edu for any other data like that. We also had a question from a student, really good question about, is there a community or platform where I can ask about research opportunities and talk with other students? Now for admissions, we do have the opportunity, we have some student hosts who do a chat with students through the admissions website, but I'm wondering if there's something like that that exists for undergrads at Stony Brook. No?
I'm not aware of anything.
Yeah, I hadn't heard of it, so I figured this was a good place to ask. And then a student asked, what I guess this was really going to depend on the research, but what kind of tasks would be given to the undergraduate student when they're working with a professor on research?
Well, that's a great one for us. Michael, do you want to give an idea, and then I can give an example? Michael, do you want to give an example of what would be an example of a project that you would give an undergrad?
I mean, I just say, here's our codes, here's a problem we're going to run. And I have a student who started working with me last semester, got him an account on some DOE supercomputers, and they've been running simulations of a particular model of an exploding star, helping to fill in some of the parameter study of models that we had run before. So they took an existing problem setup that we had, and they were tasked with running some variations of it. And there's a learning curve about using a big supercomputer and using our big codes, but this student did really well, and within a few weeks was running things, making plots, and doing really well. So that's usually what I do. Is I start a student off with trying to build on some existing simulations that we've done and maybe push them a little bit more in some new direction. And that seems to work pretty well.
So I'll just give you an idea of with Christine. So with Christine, when you start an undergrad in my lab, I got to start very carefully because, of course, I'm trying to get a feeling for how, careful they are. Some of the equipment may have 200 steps that have to be like a pilot, have to be followed precisely, or it could end up with an explosion or some other thing. So Christine had to start out with a very simple case. There was a mineral called tridymite and another one called cristobalite that were found on the moon. And the planetary scientists were not really sure what that implied and how widespread it was. So in order to have the orbiters, the satellites that are orbiting the moon, be able to figure out what this material is and where it's distributed, they needed to go into the lab with a fair amount of this particular mineral and look at its particular spectroscopic signature. The problem was that those minerals are not found in abundance on Earth. So Christine had to figure out how to go in the lab and make these minerals. And in the process, she found one was easy. She followed the phase diagram that had been developed for it. She figured out and she made a whole bunch of cristobalite that could be used. But then there was another mineral, and it has led to whole new research that she's concluded so far that mineral does not exist stably in the phase diagram that has been used since 1944. It's incorrect. So she has developed and been formulating this big research project that is something brand new that no one is aware of, that is very important to understanding the moon and then also to Mars. The same minerals are found on Mars. And it started off as something simple. But now she's deciding what experiments to run. She's analyzing it. She's going to be writing the paper, being the first author on this paper. She's going to be the one that is going to get the glory for this. And it all started with something relatively simple. So no one is going to tell you that you must come up with, some brand new theory right away. We all are used to working with undergrads, and we all know that there's a lot of fear and trepidation of, oh my God, I'm going to get in the lab and I'm not going to know what to do, and I'm an idiot, and I don't remember my chemistry that well, and all sorts of things. But don't worry, that's part of the learning experience, is getting that confidence when something doesn't work out and you have to figure out, hey, did it not work out because there's something going on here that I still do not understand, and then maybe nobody understands. And that's where Christine is right now.
So we are approaching the last few minutes. We have 4 minutes left. So we have a couple rapid fire questions. All right. So the first one is, how much do you earn doing research as an undergrad? Do you earn anything? I don't think so, right? Or am I off there?
So just to remind you that the university is not allowed, if you're taking a course, you cannot get paid. So research can be done in two ways. One is you're taking a research course which shows up on your transcript and is vitally important for grad school. Or you can say, I'm not planning to go to grad school and I need to earn some money. And then it will depend upon what the professor has budgeted in their grant for you. That is the path lesser traveled. Most people want to do the research. So it's like taking a course. No one's paying you to take calculus. So no one is going to be paying you to do research, except in the summer, because then you're not taking it as a course. And very often, it will depend. Christine, how much was your fellowship?
You mean like how much I earned from it?
Yeah.
So the stipend was $5,100, and I still have to do my taxes on it, whatever. But that's about the standard from what I've seen for research experiences over the summer. It's a couple thousand, about what you would make if you were working the whole summer.
And it's not the whole summer. It's only 6 to 8 weeks or so, right?
Yeah.
Yeah.
Okay. So any final words of wisdom for our prospective student audience that each of you would like to just maybe give a sentence or two before we have to say goodnight?
I'll start as usual. Absolutely. So when you guys are thinking about going and choosing a college, the one thing I want you to be thinking about is that not every research university is undergraduate friendly. And that what we talk all about this excitement of having undergrads do research, it's not as common as one would like. So one thing special about Stony Brook, I'll give you an example. When my daughter was at Yale for undergrad, and she was going to do a research project that linked over with the medical school. She was in biophysics. And she found out, oh, absolutely no way. There's no way an undergraduate could step foot in the medical school. That was not allowed. Whereas here we have undergrads doing all sorts of things with researchers over in the medical school. So be very cautious. Research is incredibly important in science, but not every research university is going to be as welcoming as a place like Stony Brook. So just, that's my final word of wisdom. Michael, you want to add to whatever you...
Yeah, I was looking, after 4 years of using Zoom, I still struggle to find the mute button sometimes. I would say that, research is fun. It's something that is very different from what you do in the classroom. In the classroom, there's a well-defined objective, right? We're trying to teach you something. We're trying to assess you that you've learned something. In research, we're asking a question, and we may spend the whole semester on it and realize that we asked the wrong question to begin with.
That
And
happens
so
a lot.
that's kind of what the interesting part is. You may not know if research is something you enjoy or not until you do it. And I think one of the nice things is that in both of the programs that were represented here is that there are lots of opportunities, and you start working with someone. And I think Christine said this. She didn't enjoy the first thing, and so you shop around a bit, and maybe you'll find a thing that really sparks your interest, and that's the nice bit. And I think that we have enough breadth here, again, in both of our programs, and in physics, which I'm part of as well, that you'll find your interest.
And Christina definitely has to have a last word. Most important person here.
Oh, thanks. I think what I want to relay most is that no matter your financial situation, your living situation, whatever goes on with you and your classes, you and your family, you will have opportunities at Stony Brook. There are opportunities everywhere, but especially at a research university like Stony Brook that has a lot of access to the public. There's a lot of people here. There's a lot of really good programs here. And pretty much no matter what you want to go into, you're going to find something here that's going to be so awesome. So I really, really encourage you to apply, check out Stony Brook. I really like it here.
Perfect icing on the cake. We so appreciate our panel from the College of Arts and Sciences this evening. Thank you to our amazing audience who asked over 83 questions.
Wow.
And thank you to Katie and Paula behind the scenes for supporting us. I hope everyone has a wonderful rest of their day, and hopefully we'll see you on campus. Bye, everybody.
Thank you all. Bye-bye. Thank you.